All right, in this video, we're going to talk about basic operations of matrices and also the inverse matrix. So, to add or subtract the matrix must be of the same size. So you can see here, I have a square 2 by 2. I'm adding to another square by 2 by 2, so it is allowed. So example, if we take the first matrix, 2, -5, 1, 7, 8, -3, and we add it to the second matrix, 7, 4, 3, -2, 6, 3, right? So I take 2 plus 7 is 9, -5 plus 4 is -1, and 1 plus 3 is 4. Then we do the bottom. 7 -2 is 7 plus -2 is 5, 8 plus 6 is 14, and -3, and 3 is 0. When we subtract, you can distribute the -1 and then add, or I just subtract. 5 minus 3 is 2, 8 minus 9 is -1, 4 minus 6. This is where some people distribute. 2 minuses become a plus, so it gives me a positive 10. Same with 1 minus 2 becomes 1 plus 2, which does give me 3. To multiply a matrix by number k, say k equals 8, I basically take the number outside and I distribute it through every number inside, and they stay in their same position. So 8 times -2 is -16, 8 times 3 is 24, 8 times -10 is -80, 8 times 0 is 0, and then we do the next column. I'm sorry, next row. Product of a row by column matrix is you take the first number in the row and multiply it by the first number in the column. So 3 times -6, and then you're going to take the 1 and the 5, -1 times -5. And so if we do these out, 3 times -6 is -18, plus -1 times 5, -5 is a positive 5. -18 plus 5 is -13. Remember, this is a matrix, so I still include the brackets. Homework will call it wrong if you do not put in the brackets. So to multiply a matrix together, the number of columns in a matrix must be the same number of the rows. Highlight. Columns in matrix A must be the same as the rows in matrix B. All right, that is key. If they're not, then you cannot multiply them. And so I have it listed out here, right? So again, we just do like we did before. So we're going to take 4 times 8, right? Now I'll even highlight it here. We'll do some colors here. So 4 times 8. Change my color to a different color here for a minute. And then we're going to do -8 times 3. -8, oops. And that will give us our first number in our new matrix. So 4 times 8 is 32. -8 times 3 is -24. 32 minus 24 is 8. Right? And then, clean up my numbers here, we do it all again. So, for our second top number, we do, oh, I made a mistake. I am sorry. This is my problem with having the same numbers. I wasn't paying attention. It is, backtrack here, it is 4 times 8, and then -8 times 3, just like what we did before, sorry. It's row by column, not row by row. So, that was the first one. There was 2 3s. I was not paying attention. So when we go to do our second set of numbers, we do 4 times this 3. Change our color again. We'll go green, which is here. Right, so I'll even highlight so we can see this 4 times this 3. And then we'll go to another color. And then we're going to do negative 8 times negative 4. Which then gives us our next number. So 4 times 3 is 12. And then negative 8 times negative 4 is negative 32. Sorry, positive 32. Wow, we got a few arithmetic mistakes this morning. And then 12 plus 32 is 44. So let me highlight those numbers so we can see them. Right. And then we go on to the bottom. Change this to a baby blue. So then we do 3 times 8. And we do a gray. That might be a little too dark. Let's do a light gray. And then we do negative 3 and 3, which gives us 24, minus 9, which gives us our 15. And because everything's highlighted, I'm not going to do the next one, but we could do it here. We're going to do 3 times the 3, which is 9, and then negative 3 times negative 4, which is positive 12. 9 and 12 finally gives me my 21. Sorry about the little bit of mess up at the beginning, but you can see we all kind of take our times with this and write it out. And we can do a problem where we're adding and multiplying at the same time. Just like PEMDAS, we do multiplication then add. So B plus AD, I'm going to take and multiply A and D together. And I have it all written out here. Again, first row multiplied by the first column. So I'm just going to do just that one so I don't make it too difficult to read here. So we're going to multiply 9 times 3. And then 7 times negative 8. And do yellow. Negative 9 and 0. Which gives us what? 9 times 3 is 27. 7 times negative 8 is negative 56. And 9 times 0 is 0. Add those together, and you get your negative 29. And then you'll do for the next number, in the first row times all of the next column. So 9 times 1, 7 times negative 2, and 9 times negative 1. Do all those up. So 9 times 1 is 9. 7 times negative 2 is negative 14. And then negative 9 times negative 1 is positive 9. 9 and 9 is 18. Minus 14 is 4. And then we'll do the exact same thing. So it's kind of, but it's interesting. I have column A is a 2 by 3, and D is a 3 by 2, right? So this is a 2 by 3. This is a 3 by 2. And notice what do we finish with? We finish with a 2 by 2. Right? And that will always happen when I'm multiplying. And now I add. I just take what my multiplication together, which is right here, and I add it to our B. And so again, negative 5 plus negative 29 is negative 34. 1 plus 4 is 5. Negative 2 and 11 is 9. And then 9 minus 2 is 7. An identity matrix we already talked about, but is a square matrix where the primary diagonal starting in the upper left corner to the bottom right is all ones. So basically you get a diagonal. I want to write them out. A diagonal of 1s or a diagonal of 1s, and everything else is 0. So you can find an inverse of a square matrix by taking our original matrix M, or whatever letter you use to identify, and multiplying by its inverse. And any matrix times its inverse equals 1, which means it equals an identity matrix. And you can use the methods we've learned last week, or in previous lessons, to swap the two matrices to find the inverse. So for example, if I have, sorry about my water pump here, if I have 2 minus 3 and 3 minus 4 is my matrix M, so right here, M, oops, I'm still in highlighter mode, sorry about that, pen mode, pen, thank you, M equals the matrix 2, 3, negative 3, negative 4, and then I multiply it by an identity, I will get my inverse. So if I do 1/2 of row 1, multiply row 1 and then replace row 1, right? So half of, that's what we did last week, but a half of 2. I'll do a few of these just as a refresher. Half of 2, and then 1/2 of negative 3. And you have to do it to the identity matrix as well, so 1/2. That's my pen here. 1/2 of 1, and then 1/2 of 0. Well, 1/2 of 2 is 1. That's right here. And then 1/2 of negative 3 over, wow, why? Because my thing keeps turning off. There we go. So it becomes negative 3 halves. 1/2 times 1 is 1/2, and 1/2 times 0 is 0. And then this becomes my new first row, just like we were doing in previous sections. And then I go into step 2. I multiply negative 3 times row 1, add it to row 2, and I do this again because I want my 0. And after I finish these next 2 steps, I get my 1, 0. Right, and so it says to multiply negative 3, we can do this real quick. Negative 3 times row 1. So I'm going to multiply negative 3 times all this up here. So negative 3 times 1. Negative 3 times negative 3 halves. Negative 3 times 1/2. And then negative 3 times 0. And then negative 3 times 1 is negative 3. This comes positive 9 halves. Negative 3 halves, and 0. And then I add it to my old row 2, so 3, 4, 0, and 1. Add those together, and I get 0, 1/2, negative 3 halves, and 1, and that becomes my new second row. And then step 3, I multiply row 2 by 2 and replace row 2. So if I multiply this by 2, I get 2 times 0 plus 2 times 1/2, 2 times negative 3 halves, and 2 times 1. I then get 0, I get 1, I get negative 3, and I get 2, and this becomes my new second row. And look, again, now I have my 0, 1 here. And the reason we're doing this is we're trying to take our old matrix, we're basically swapping the places. We're taking, where we started up here, our identity matrix on the right, and we want to make it on the left. And we're taking our matrix M and moving it to the right, which will create our inverse M matrix. And then our final step, we'll multiply a row 2 by 3 halves, add it to row 1, and get row 1. So if I take 3 halves and multiply it by row 2, and the reason I know it's 3 halves, again, is I got to get rid of this guy. So I just basically take the inverse of him, the additive inverse, which would be a positive 3 halves. So 3 halves of row 2. So 3 halves times 0 plus 3 halves times 1 minus 3 times 3 halves, and then 2 times 3 halves. Well, this is still equal to 0. The 3 halves times 1 is 3 halves. Negative 3 times 3 halves is negative 9 halves. And this becomes a 3. And then we're going to add it to row 1. So we got 1, negative 3 halves, 1 half, and 0. We add them together. And we get 1, 0. So we add these together, and that gives us 8 halves, which is 4. Negative. And then we get 3, and that replaces up here into row 1. And now our matrix on the right here is our inverse matrix. So our inverse matrix is negative 4, negative 3, 3, 2. All right, I will make a separate video for the next 2 sections. Please leave comments or reach out if you have any questions. Thank you.